Good everyone. I hope you're having an amazing day. So today I'll be talking about another aspect of code refactoring, that is violation of interface segregation principle. Now, interface segregation principle is one of the part of solid principle. So which means that too much of interface can be bad. So I mean, you shouldn't be writing an interface in such a way that your client or a class which consumes the interface shouldn't be forced to implement a method which is of no use to the class. Okay. So now you must be wondering what the heck I'm talking about. So let me demonstrate that to you and hope that will become clear. Okay. So I'm going to create an interface. So let me create a class first. So I would say I will create an interface for associated with an authorization. So I'll just create it as IAuth. So I'll just say public interface, and I have a method. Let's say I'm building this uh, interface to keep um, IAuth authorization into consideration. Okay, so what I will do say string client ID. So what is it? String. Um, oh, sorry, not string secret key. For the time being assumed, I'm adding few components to auth. So string username. So let's say this will generate an access token, right? So password. Yep. So string grant type, right? Whatever the grant type it is. If it's a password or something. Okay, so this is the auth interface what I have. Now I will be creating a dummy class, which is a client, whatever you wanted to say. So I'll just create another Apex class, and I will say, uh, oh, uh, let's say main. That's a main auth class, right? So I'll just say implement, yeah, this one. Okay, so we'll copy this method here and just keep it public string. I'll just add a body, just dummy string, yeah. All right, public. Wait, uh, let's say returns nothing, right? So just a blank string, yeah, return. Just for the sake of demo, this will do the job. Come on. Oh man, this is interesting. Right, okay, let me close this one. I always try to mimic the real programming experience, like a developer do the stuff. That's why I try not to copy paste in advance. So it defeats the whole purpose, right? I mean, I wanted to make it as much as realistic as I can. So it's like as if I'm doing a real development. So I mean, I've done this mistake, so I just thought it's better. I can teach other people so that you guys don't do the same mistake. So too much of interface, right? It can lead to interface smell, so which is not great. Okay, so this is a so you must be wondering, right? Okay, I got a main authorization class which implements auth. I authorization interface. So this looks pretty cool, right? There's nothing wrong with that. Yeah, this is fine. At this stage, everything is okay. I mean, because you got all of these methods will be used by a main auth, which is a part of auth interface, which is great. Now, think about a scenario where you wanted to implement a basic interface. Okay, so which only deals with username and password. So as usual, so what did you so basic auth, yeah. Um, okay, so what I'll do, obviously, a developer decides to do something like this. Say, okay, I got an interface, so why not I do this? Okay, you might have seen this code before, something similar, right? Okay, this looks pretty okay, so let me copy paste it. Um, yeah. So, and I will use only the. Hang on a second. That looks good. And you'll say, okay, and I'll only use the username and password. So rest of them is pretty useless for me anyways, because basic got nothing to do with the client ID, secret key, and grant. So now you see the problem here. This is what I call interface smell, because IOT interface is not useful for basic auth, because it's only need ID and username, right? Sorry, it only needs username and password. Okay, so so some of the developers might say, okay, so I don't want to use auth. Okay, so might as well have, I don't want this. So what I'm going to do instead, so they always have a clever idea, right? Because I've been a developer at one point of time. I mean, I still code, so coding is amazing. So what they do? Okay, I say I basic, sweet, I basic, right? Now, and they say, okay, I basic is pretty cool, so I will do interface. All right, so I will copy paste these two things here. All right, this is all I need. Right, so this is pretty cool, and I'll go here, go to my basic. So I'll just say my basic, which is pretty cool. So I don't need any of this stuff. So I'll say, all right, this looks pretty cool. Compared to the previous implementation, this looks okay. This looks better, much better. But there's still a problem with this one. Okay, I'll tell you in a second. Right. So now it's not a problem about interface smell anymore, because basic auth is not implementing methods which is not a part of basic auth, right? Because there's no need of secret key or client ID or the grant type, right? Because that's a part of auth interface or the main authorization class, right? So this looks pretty okay. I mean, it will do the job, but still there's a problem there. Like if you look at um, this authorization, right? There is a duplication. So see, the username and password is duplicated in this interface as well as in this interface. So which is not good, right? This is a problem with the duplicate code duplication, right? So you have two interface. Think about it this way: you have two interface, right? Interface one and interface two both shares a common methods, right? Username and password. It doesn't make sense, right? Why not move this username and password to a single interface and keep the old one here? So what I mean by that is, now delete this one here. Oh, sorry. So keep this, okay, right? Um, and go to the main. So what do you do? Implements. There you go. It does the job. So you're implementing two interface, right? One is the basic, which does the basic username and password, and one is the auth, which to do with the auth interface, right? This is what I'm talking about, interface segregation principle. If you have a big chunk of interface, which makes no sense for certain classes, split it out, right? That's the best way you can do it, right? And this is something very commonly used in .NET or in Java. So if you haven't seen something similar in Apex, I would highly encourage you to read about Solar Principle. It's pretty amazing principle. I think it will help you to write a better and efficient code, right? At the end of the day, like I always say, code is not just a code. It's an asset to a company who invest their money and time on you to develop the solution for them, right? So it's like you're building a house, right? So you're a developer who wants to build, who've been given a job to build a house, right? Now, if you build a house in a shitty way, right? Eventually, over the course of time, right, it will collapse, right? It will have complications, right? There's an issue with the foundation, or there's something, blah, blah. I'm not a builder on the building side, but you get what I'm trying to say, right? So that's why it's very important to have a well architected code. I've used to have a concept called software architects. I mean, I think that we still do, it's more main job of the software architect is to understand from a business perspective as well as from a technical perspective, right? From a technical perspective, how different classes will tie together and how the interface works, which interface should belongs to which class, and if we can split the interface, right? Can we do a dependency injection where we have to do a dependency injection, or are we doing too much of dependency injection, right? Or are we doing too much of code reuse? That kind of stuff, right? That's where a good architecture is very important, right? Before you start even writing a single line of a code. So it has to be architected in an efficient way. So that's why I always suggest code refactoring plays a very important role. So if you're a tech lead, or if you're a senior developer who's reviewing a junior developer code, these kind of things you should look for. It will help in the future to clear the tech debt, because if the code base grows with this kind of a code, then you might end up in having a lot of issues, right? Because a new developer will join the team and they will start using a different standards, and then another developer will join the team, they will use the different standards. So it's good to have a certain fixed standard, a proper standard which complies to a proper object oriented design pattern, right? So that's very important, right? So I think if you see a code like this, it's an opportunity for you guys to go and fix it, right? Like I said, I hate the saying, where people say, okay, when something is not broken, why you go and fix it, right? That's a very bad attitude, right? Right? It's like saying, right, someone else is affected. Like if it's like, let me give you a very harsh example, right? Very harsh example. Please don't take it personally, but I'm just giving you a. If you see someone, someone had an accident right on the street, would you say, it's like, look, it's got nothing to do with me, I'll let him, her, or die? You won't do that, right? You probably call 111 and say, okay, let me get that person straight away to hospital. That's the same analogy you should have towards the code. It is a code. It is a critical stuff, right? It can cost you a critical, code smell, a critical technical debt, which is very, very bad for any company, right? You know, Ideally speaking, in my personal opinion, if a developer causing too much of code issues, you know, a developer should be penalized for that in terms of the pay should be cut, because it's causing a company hell lot of money, right? I sometimes known to go for extreme means, but this is something I always believe, that if a person do not know how to do things, it's good to teach them. I'm very open for that. It's very important that someone joins the team. It's very important to make them feel comfortable, teach them. But if a person is doing mistake over and over and over and again, just get rid of them, right? I mean, they're not a good fit. They should do something else, right? So that's why when I see a code like this, it just baffles me when persons say, I have 10 years of programming experience, really, and you like a shitty code like this. It just makes me wonder what the heck they've been doing for the past 10 years, right? So yeah. So that being said, I'm gonna talk about dependency injection issues next time. I mean, it's very commonly I've seen, right? Too much of dependency injection, right? You inject this interface there, inject that interface there, right? This is just it's like a dependency smell everywhere. Once I finish that, we're going to talk about Salesforce identity aspect, right? We're going to talk about single sign-on. We're going to get into an architect side of things more, because I'm going to stop doing coding aspect, because I think I've done a lot of programming to teach you guys. Now I wanted to get more into architecture side of things, right? because I haven't seen much architecture videos out there. I mean, there are a few. There are a few great videos. I've seen a lot of user groups in India that does pretty good, and the United States are pretty good stuff as well, right? So I just wanted to do something in New Zealand. So that's the main purpose of all of this stuff, right? Cool. All right. That being said, you guys have an amazing Thursday, or if you're in Europe, probably yeah, it's Thursday morning, right? Okay. Adios.